Alright, hello. So we're going to work through a concrete example of camera equations. So we're going to take a concrete triangle and then go from the triangle being defined in world coordinates to being defined in pixel coordinates concretely, and both in on like a blackboard and in the code. So, alright. So let's first take the triangle. So here I just chose a bunch of numbers. So triangle is defined by 3 points, and it starts in coordinates of 3 points in 3D space in the world coordinates. So in world coordinates, our triangle is going to be like this. So there's 3 points, right? So point 1, point 2, point 3, and then the point is going to be defined as x, y, z coordinate tuple, right? And it's going to be exactly as I defined above. So 0, minus 2, minus 1, and then 0, 1, minus 1, and then 0, minus 1, 1. And then I have drawn this already, but like let me redraw it together so that we understand it together. So I start with coordinate system. So like this. So it is x, y, and z, and those 3 points are in word frame. So maybe a really quick comment, right? So just to define those poses properly, as we did in SE3, right? Point doesn't really have a rotation, right? So, but still, we would write something like this. And then the first point, so there will be a bunch of zeros here and 1 here, and then the first point would be like 0, minus 2, minus 1. That would be the this point, right? And then that would be the second point, and then the third point would be, of course, minus 1, 1. But like, because the points don't really have orientation, it doesn't really matter. So yeah, I just wrote them like this, skipping all this like unit rotation. But yeah, if I wanted really to work my way through this in proper way, I could write this. But sometimes, for the sake of computational efficiency, we would just like omit this and just only treat it as so-called homogeneous coordinates. So a point is like, 0, minus 2, minus 1, 1, and then this 1 at the end is like this homogeneous, right? There's like a distinction between like a vector and point, so 0 and 1. But yeah, this just wanted to mention this real quick. That's what sometimes people do. So wanted to mention this, but it's sort of beyond the point of the current experiment or the current exercise. So coming back, let's just draw those points, right? So they all have 0 x coordinates, so they're going to be in this like zy plane. So in 3D it looks something like this. So it's like minus 2, so minus 1, 2, and then minus 1, so it's like something like this. So somewhere here is point number 1, and then point number 2 is like 1 minus 1, so it's like 1 and then minus 1 again, so it's somewhere like here. This is point, so P1, P2, and P3. And then, so this is like P1, right, P2, and then P3, that's going to be minus 1, 1. So here's 1, somewhere around here. And here's our triangle, P3. And yeah, let me like even use colors, right? P1, P2, P2, and maybe blue, P3. Right. and then you're going to place camera at point equal x is -5, y 0 and z 0, right? So that will be our camera. Actually, yeah, let me draw it. So it's like 1 2 3 4 5. Here should be our camera, so we draw an eye. It's not particularly pretty, but that's fine. And then it's going to look in this direction, right? And actually, let me move those over here. And then, like, I know you know, but just for super clarity, let me draw like a section in zy, so y and z, and just like looking towards positive axis as if we were the camera seeing it. So the first one is wait, I messed up. So yeah, this is y and this is z, and then it's like 1 1 1 1 and 2. So -2 -1 is here, p1, and then 1 -1 is here, and then -1 1 here. Here's our triangle. And yeah, if we so and all of this is like in word coordinates. Then we want to we will want to transform this point into camera coordinates, and then place in unit distance in front of the camera, like over here, pretty much a picture. And the picture is going to look somewhat like this, right? It's going to be kind of similar, and then we're going to project. So yeah, let's just work through the math on the like this virtual piece of paper for now, and then we're going to try to implement the same thing in the in computer. So so in order to figure out like a position of the point in camera, yeah, actually let me be really careful about the coordinates, right? Because like I want to remind you that there is this coordinate flip, right? So first we're going to have like so this is in word frame. Here's the triangle, and here's the camera looking towards the triangle, right? It's going to be something like this. And yeah, actually it's even different. Let me draw it how it really is. So first step, we have this, and we have this, and then here's the triangle, right? In this like sort of around the unit. So the triangle exists around the beginning of the coordinate system, and the camera is pretty far away from the coordinate system. So this is, we're going to call this word, and then we'll so this is words, and then in camera frame, that's going to, so the beginning of the coordinate system will be in the where the eye is, right? So something like this. So it's just literally bringing the beginning of the coordinate system to the where the camera is, x, y, and z, and then we're going to bring this to image frame, right? And remember how the image frame was such that, oh yeah, so maybe in camera frame, right? So it's like around +5. The triangle will be around +5. So this is like word and camera, and then there's image, right? So image frame, remember how the z points out of the camera. So this will be z, and then so this is how the picture looks like. So x points right? So we will have this axis over here, but it's going to point in the another direction, right? It's going to be x, and then y will also point downwards. So here's like the optical center of the camera, right? It's just purely the convention to shift it into this you know, usual convention of the picture. So this will be the, let's call it the image frame, right? The image frame, or like the flip. You can call it the flip frame as well. It's not something that people use, I just use it, right? And then at z equals 1 in this flip frame, there's like this continuous image plane towards which will project the actual image of the triangle. And then we'll have the pixel frame, right? And the pixel frame will be actually kind of like 2.5D, honestly. And this will be purely, so the orientation of the axis will be the same as here, right? It will be like yeah, it will be like X and Y, but the image will begin here and it will have pixels, right? So it will be measured in pixels. So that will be different, right? So we need 3 steps. We'll need 3 steps. Or maybe even there's 2 steps here, because there's like this projection and then the linear shift in the coordinates. So yeah, pretty much that's it, right? So let's maybe work our way. So yeah, first maybe a reminder. So in order to have, let's say that we have the point, we want to have the point in camera. How do we do this? So we need camera here, and then we have word in camera. So this is like inverse of the camera in word. This is pretty much just pose of the camera. And then we also have position of the point in the word, right? So it's just given. So this is this thing over here is the position of the, or like it can be made into position of the point in word, right? So this is sort of the first thing. And then just to continue this thought, right? So if we want to have like t in image, or like the flip, maybe let me call it flip. The position of the point in the flip is like flip in cam, t cam word, and then t word point, right? So position of point in the word, then inverse of position of cam in the word, and then position in cam of the flip, sort of like a transformation of flip matrix that like flips those coordinates around. So yeah, that's how it's going to look like. And maybe let's work numerically through this one, just to make it really abundantly clear, right? So over here we have defined the position of the camera in word, so that's -500. Let's work our way through this example over here. So position of the point in camera frame. So that's going to be so inverse of position of camera in the word, and that's 1001 like this, and then that's -500. And then if we invert it, what you would see is the following. It's this, and then 5 1 1, and like why it's like this, because so if we have our coordinate system, right, then our camera is over here at -500, right, sort of bird's eye view is X and then Y, and then camera is here looking in this direction. So what's the position of this point in this coordinate frame, right? If I just start this, if I start drawing the coordinate system right over here, right, just for a second, then I will see that it's like 1, 2, 3, 4, 5 at x equals 5, and then y equals 0, z equals 0, right? So camera was at -5 away from the old coordinate system, which was here, and then the beginning of the old world is 5, +5 along x in the new world y, right? So it all makes sense, and also it happens to be the inverse of this matrix. So it's nice. It makes both, like, you know, mathematical sense and intuitive sense. So yeah, I encourage you to work through slightly more complicated version of this, right? And then, so yeah, so this is like position of word in CAM, which is inverse of position of CAM in the word. And then here we will have position of the point in word. What was the, like, let's take 1 point, and now let's take the 0, -2, -1, 0, -2, -1, yeah, and yeah, pretty much you just multiply those two, and then you will get this, like, position of the point in the CAM. And maybe you can guess what it is. It's literally just addition of those two. So that will be like this, 5 -2 -1, and then yeah, we'll flip the coordinates, we'll project them back to z, and yeah, that will be our position of the point in the image, right? So let's see how it works in practice. All right, so I do have where's my mouse? Here. Okay, so here I put my triangle x, y, z. Makes total sense, right? The shape of the triangle is different than it says over here. It's 3 by 3. That's true. Alright, and then position of camera in the word is -5, 0, 0, so pointing towards x direction, and then at x equals -5, at y equals 0, z equals 0, right? That's how it works. Okay, so this is the coordinate flip that we will use later, right? And like, notice this convention, right? So like I was writing before, like t, and then the word was here, sort of, right, before the t, and then cameras was after, right? And then I write it camera in word is this like naming convention that I use. And then here we have camera and flip, which will be this flip or like image coordinate transformation matrix. But yeah, this is not important right now. And yeah, so so here I transform this simplified 3D coordinate into the full SE3 matrix. So I start with identity matrix, and then I just like fill in this last column with the coordinates, and I get 0, -2, -1, so x equals 0, y equals -2, and y -1. And for now I just do it for one vertex of the triangle. And then So we had this equation before, right? So if I want to have like com t point, I need to have two things. So I need to have com t word, and then I need to multiply this by word t point. So here's vertex in word, which is this, and then I need this. So I already have something called, so here I would call it like point or like vertex in com equals, just translating the naming conversions. So word in com times vertex in word. So purely, so word from here cancels out with this one. So okay, so I need word in camera. I get it by inverting the camera in word. Let's just like validate it real quick just to see how it works. So cam in word is this, and then if I invert it, how does it look like? Yeah, it flips this one, right? So as we have predicted on the piece of paper, so we get yeah, maybe I just leave it. We get word in camera, and then we transform the vertex to the camera, and then indeed we get 5 minus 2 minus 1, right? And then like being careful about the coordinates. So again, now we need to flip. So we need to just like let's remind ourselves how it worked. So we had like x, y, z, and then we want x to become z. We want y to become negative x, and then we want z to become negative y. So that's how I will just like show the picture again real quick, just to make sure it makes sense. Oh, come on, show us the picture. So sad doesn't want to connect right now. Let me just show it like this. So have like this, like this, like this, and then another one, right? So like this, like this, like this, and then here we go, bum, 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 x, y, and z, and then we want this, so z, so points away from the camera, right? It points away from the camera, and then x points to the right, x, and then y points down. So the picture is like this, right? X, y. Yeah, so x becomes z, y becomes negative x, and then z becomes negative y, right? And that's what we see here. So so this is like inversion of this. It's kind of hard to see this, but let's say I do like np in alk in camera in flip, camera in flip. So we're more defining in terms of like, oh, come on. Yeah, so x becomes z, right? X becomes z. Y becomes, oh, we're missing a minus. We're missing a minus actually. Interesting. y becomes, so x becomes z, y becomes minus x. So wait, do we need like minus here? No. Do we need minus here? Yes. All right, now it's good. So x becomes z. That makes sense, right? So first coordinate to third coordinate. Then y becomes minus x. Then z becomes minus y. So the second coordinate becomes the first coordinate, and then third coordinate becomes minus 1. So this is like our this would be like what's the flip in camera, but actually going to use camera and flip. So we just directly define camera and flip. So all it does is just flip the coordinates, right? And yeah, we're going to be able to validate this just like by looking at the end of the numbers, and this is like a nice way to debug this really. So right, so we were here, we have defined so we have mapped the vertex to the camera coordinates, and then flip them, and so let's go back to the picture over here. Let me see, can I like share my screen? Yes. Okay. So we're here. X, Y, Z. Camera was here. So here was our real beginning of the, yeah, maybe I just erase it. So camera is here, and then like 5 along here, there's our point. So x equals 5, and then y is minus 2, so 1 and 2 over here, and then z is minus 1 over here. Here's our point P, and then we want to flip it to those coordinates where it looks somewhat like this. This. So z, x, y. So we want z to become 5. So z points away from us. Then y was minus 2. So it's like to the wait. I misdrew it. So y was minus 2. So it's like 1, 2. And then z was minus 1. Minus 1. Here it was. Yeah. So we want x to become 2, and then we want z to become not z. We want y to become, so it goes down. So it's actually I'm making so many small mistakes. Sorry. Minus 5 minus 2, and then minus 1 down, and so we want y to become 1, and then so what it means is it's like x equals 2, y equals 1, and then z equals 5. So we expect 2 and 5. Let's see if that's what we get. We get wait, minus 2, 1, 5. guessing. Why doesn't it work? Come on. Don't I have like ping or something? Pom, pom, pom. Pom, 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 pom. Mm-hmm. So like y becomes no. Yeah, y becomes x. Does it make any sense? No, it does not.